So now we're going to be taking a look at zero and negative integer exponents. So we have a couple new set of rules. What I'm going to do first is show you these rules, and then we're going to go ahead and explain them. So the first rule you'll see is that a to the power of 0 equals 1. Essentially that means anything raised to the power of 0 will equal 1. Might sound confusing, but I'm going to explain that. I'm also going to show you how a base raised to a negative exponent will be the same thing as 1 over that base raised to the positive exponent. So hopefully you'll see the relationship between a negative exponent and its positive value in the denominator. So let's start with the first. We stated that a to the 0 equals 1. Well, let me start out with an example. What I'm going to do is take 2 to the 5th divided by 2 to the 5th. Now, what you'll notice is using the laws of exponents here, I have similar bases, so that means I'm going to take 2 to the 5 minus 5. And that equals 2 to the 0. However, if I use direct calculation, so we have 2 times 2 times 2 times 2 times 2, right? 2 to the 5th divided by 2 times 2 times 2 times 2 times 2. What we see when we start to cancel out values, let's see, these cancel, these cancel, these cancel, these cancel, these cancel, and we're left with a value of 1. Because really anything divided by itself is 1, so what you'll see, hopefully, is that 2 to the 0 equals 1. Now this also holds true with variables, so it doesn't necessarily have to be just numerical values. What we're going to do here is the same thing. So I have a to the 3 minus 3, again using our laws of exponents. So that's going to get me a to the 0. And if I use direct calculation, I have a times a times a over a times a times a. So we could see anything divided by itself, right, is going to equal 1. And if we were to cancel out those values, in case you didn't see that, you see that everything cancels and we're left with a value of 1. So again, we see that law of zero exponents, that anything raised to the power of 0 equals 1. Now what we're going to do is take a look at negative exponents. So the first thing I'm going to do is we're kind of going to do the same thing we did on the last page there. I'm going to start with the laws of exponents. So 7 to the 3rd divided by 7 to the 5th means I have 7 to the 3 minus 5, which means I have 7 to the negative 2nd. Now, if I use direct calculation, I have 7 times 7 times 7 divided by 7 times 7 times 7 times 7 times 7. Now, as we start canceling values out, we cancel out once, we cancel out twice, we cancel out thrice. Now remember, whenever you cancel out values and there's nothing left in your numerator, your placeholder is a value of 1. And then what I'm left with is 1 over 7 times 7. So 1 over 7 squared. So what we can see, hopefully, here and here is that 7 to the negative 2nd is the same thing as 1 over 7 to the 2nd. So I've made that negative exponent positive by moving it over to the denominator. And there is a shortcut that we're going to explore more as we talk about this in class. Now, again, with a variable here, I'm going to go ahead and take a to the 4th divided by a to the 7th. So I have a to the 4 minus 7. And that's going to be a to the negative 3rd. Now, if we want to watch that magic again using direct calculation, I have a times a times a times a divided by A times A times A times A times A times A times A. And when we cancel out values, we see again that I need that placeholder of 1 in the numerator, and then I have A times A times A, which is A to the third. So once again we see over here that A to the negative third equals 1 over A to the third. Again, I have made that negative exponent positive by moving it over to the numerator of a fraction. And that's our goal. You usually want to leave your exponents in positive notation. You don't want to leave your answers in negative values. So, how does this work in terms of working with positive and negative exponents? Well, the rules are essentially the same. So again, if you want to try it out on your own, you can go ahead and pause. I'm going to work on these and then you can follow along. So I have 7 to the negative fifth times 7 to the fourth. Well, what I'm going to go ahead and do here is use my laws of exponents. I have similar bases, so that's going to equal 7 to the negative fifth plus 4, which is going to equal 7 to the negative first power. However, I don't want to leave my answer with a negative exponent, so the shortcut I remember is that I can put this as 1 over 7 to the first. Now, 7 to the first is a little redundant, so we don't need that 1. We can just leave our answer as 1 over 7. My next example here gets a little tricky, but if we remember, it's a couple steps. I have a to the m to the n. So that means I'm going to multiply my exponents together. I'm going to go ahead and do that first, right? Order of operations. You're going to multiply before you divide. So this is going to get me 3 to the negative 12th divided by 3 to the negative 10th. Now that might seem confusing, but here's where the order of operations and the laws of exponents actually help us perform an easier operation. Because this is going to simplify to 3 to the negative 12th minus a negative 10. Now if you're subtracting a negative 10, that's going to be the same thing as adding a positive 10, so this is going to get me 3 to the negative second. My answer, however, is not done because I have a negative exponent and I'm going to make it positive by putting it in the denominator of a fraction. So those are the steps for now using positive and negative exponents and zero values. Now I'm going to go ahead and leave you with a challenging problem, which will, when we discuss it tomorrow, help illustrate the shortcut between positive and negative exponents. So what I want you to do is evaluate the following. Now evaluate, that's a new word. That doesn't just mean to simplify using exponents, but it also means to solve. So whenever you see something evaluated, you want to make sure to give the final numerical value after simplifying. So good.